Yo, this is Mr. O. Today we're gonna go with solving absolute value inequality. And let's go ahead now. We know that this is called greater than or equal to. But for solving absolute value, to make our life easy, let's read this one as greater. Why do you think it's greater? Every time you have an absolute value inequality, it's already isolated, and the inequality attached to that one is a greater sign. It reminds us that it's an or problem. It's an or statement in a compound inequality. For this one here, we know it's called less than or equal to. We will call it less than. So we know we can associate this one as an and problem. So let's try this examples here. Looking at the board, our first problem is absolute value of a greater than or equal to 3. Since this is a greater problem or problem, we can say that this is an or disjunction, a greater than equal to 3 or a less than or equal to negative 3. If you notice what I did here, I split them into two inequality, simple one, that wherein a is greater than equal to 3, which is basically this exact same question, but the other one, I flip the inequality to a less than, but I made the constant to be negative. With that, let's see how we graph it. A greater than equal to 3, the 3 is right here. This will be identified to be close. And what are the numbers bigger than 3? Everything on the right side. And again, this is pointing to the right. While the other one, negative 3, is right here, which is also going to be close. That's negative, but it's pointing to the left, so everything on the left side. And that's our answer. For number 2, x less than and less than. An and statement means we're looking for the intersection or the conjunction. So since this is less than, it's an and problem, we're going to do the same thing. X less than 9, I copy the problem excluding the absolute value, and I will write here the word and I will also do the same thing as what I did in number 1. I copy x here, but the inequality will flip and make this negative 9. If you notice, same thing with number 1, I flip the inequality and then I flip its sign. Same here. I flip the less than become greater and make it negative 9. So now, since we can graph it, the 9 here is right here. This is the 9. It's open. It's going to the left. And the negative 9 is right here, open, going to the right. Did they intersect? Yes, the black and the purple intersected right over on this area. Easy, right? Next. Number 3 is the same thing. Since this one here is a greater, it's an or problem, we can say x greater than 10, or what do we do again with the inequality? X flip less than and make the 10 to be negative. So we know the 10 is right here, going to the right. The negative 10 is right here, going to the left. For number 4, this is less than an and. So this will be n less than or equal to 6. And what do? Flip it and change the sign to make it negative 6. The 6 is going to the left with close. And the negative 6 is going to the right, close. And we know that it intersected right over on this area. Now, what if there are operations inside the absolute value? We just have to solve it separately into set. So what do we do here first? Identify, is this an AND or OR? We know that this is an AND problem because again, it's less than. -8 plus n less than or equal to 6. I just copy the problem excluding the absolute value and write the word n here. And -8 plus n, I'm just copying the expression inside the absolute value. But what do I do with this one here? I flip it over and make it -6. From there, I can solve the problem separately, adding 8, and less than or equal to 14, and plus 8 here, plus 8 there, and is greater than or equal to 2. So that is our answer as of right now. Let's graph it. Let's double check if this is correct. Again, it's an end, so we expect an intersection or intersecting graph. The 14 is right here, is close, going to the left. 2 is all right here, is close, going to the right. Did the blue and red intersected? Yes, intersected right here, so we can just connect them. Simple, right? Number 6. We have a greater or problem here at this junction. So again, what we do, we just copy the 5x, not including the absolute value, greater than 30, or -5x. Now we have to flip it and make this -30. We solve it by dividing by -5, and every time we divide by negative, what happened? We switch it, the inequality. X less than -6, or divide by -5 here. X, we did flip it again because we're dividing by -6. So let's check if this is correct answer. The -6 is going to the left, and the +6 is going to the right. And as an OR, this junction, we combine all the possible work for each inequality. Okay, thank you. Let's go to the next one. 7. Here we have an operation outside the absolute value. I see a -6. The -6 is being multiplied here to the absolute value. So what's the opposite of multiplying? We're going to divide this by -6 and -6. We will cancel this. And what's left is absolute value of x plus 5 less than or equal to +2. If you notice, I did not remove the absolute value yet because I need to isolate the absolute value sign before splitting them into 2. I will not judge that the problem is a greater problem until you isolate the absolute value. In this case, from a greater, it becomes less than because I divided by a -6. So it has to be flipped. So again, as a reminder, do not assume it's an AND or OR problem until you isolate the absolute value first. So in this case, it's a less than. I will split them in 2, x plus 5 less than or equal to, and x plus 5 greater than or equal to -2. Solve it, -5 minus 5, x less than or equal to -3, -5 minus 5, x is greater than or equal to -7. Let's see if this is really going to be a conjunction problem. We expect to intersect. -3 is right here, going to the left, and -7 is right here, close, going to the right. So we know that this is the answer, the intersection, the intersected. For number 8, is the absolute value signed by itself? Not yet. There's a 9 underneath of that one, which is not part of the absolute value. So what's the opposite of dividing by 9? We multiply by 9. Do we need to flip the inequality? You're right, we do not need to because we're not multiplying it by a negative number. So what we need to do here is just cancel the 9s. The absolute value will remain as 6 minus 2x greater than equal to 36. Now, Since the absolute value sign is by itself, we can split them into two as 6 minus 2x greater than 36. I just copied the expression, the entire inequality without the absolute value. Or 6 minus 2x less than or equal to negative 36. I flip them again. Solve it by subtracting 6. That gives me drop the negative 2x greater than equal to 30. Now I'm dividing it by negative 2. That makes it x flip over negative 15. Minus 6 also, minus 6, negative 2x less than equal to negative 42. Divide again by negative 2. X is greater than equal to 21. So where's the graph? The negative 15 is right here on the left, going to the left there, and the 21 is somewhere here going to the right. Because we're expecting an OR problem. Easy, right? Next. For number 9 and 10, remember anything inside the absolute value, no matter what the case, it could be 0 to have one solution, or it could be any possible answer as long as it's positive. There will be no way that you can have from an absolute value to produce a negative answer. So look at this one here. If you add 3 here, if you add 3 there, you're telling me that you have an absolute value of 4 plus 5n less than negative 21. You're saying that whatever the answer may be here will produce something smaller or less than negative 21. Is that possible? No, because anything inside the absolute value, whatever you extract there or whatever simplification you come up in inside the absolute value, it has to be a 0 or a positive. So meaning to say, it's impossible for you to have something less than negative 21. So therefore, this is a special case. The question is this a no solution or many solution? Since this one here is a less than, the answer would be a no solution. Why? Because it's a false statement. So the answer is no solution. While here, minus 1, it will give us absolute value of 5x plus 8 greater than or equal to negative 47. I know it's not going to produce a negative answer, but think about this. This is an absolute value. It will always be positive. Will this be always, sometimes, never, bigger than a negative 47? The correct answer is that it's always going to give you a bigger number than negative 47, because this will create a positive value and it will always be bigger than any negative number. So since this is a true statement, this will be many solution or all real numbers. I hope you guys learned something. Again, today is the greater and less than. Kaboom!